I'm Zato from University Malaysia Terengganu. In this video, we will conduct two experiments where we can do it by own at home, which are salt crystallization and sugar crystallization. So let's get started. Crystals are solid materials made up of elements, molecules or compounds arranged in regular repeating three-dimensional pattern called a lattice. May be microscopic or can grow in large crystals. Crystallization is the process by which a solid forms, where the atoms or molecules are highly organized into a structure known as crystal. Crystallization can be done by solidification, precipitation, and recrystallization. In this experiment, we will focus in precipitation by evaporation and cooling process to form crystal.
So this is what we need for our experiment.
Let's start with first salt crystallization. I'm using around 400 ml of hot water. Then add salt, dissolve it. For this experiment, you need to dissolve salt until no more salt can be dissolved in this solution. So as you can see, after a continuous stir, there's remaining salt here. That means this salt cannot be dissolved anymore in solution. I use a little bit of food coloring to differentiate between my salt crystallization and my sugar crystallization. Okay, let's separate the solution and the remaining salt. This is the remaining salt here. Let's put the stick and paper clip as a quarter. So now we will continue for second experiment, sugar crystallization. I also use for 400 ml of hot water. Add sugar to the hot water and dissolve it. This procedure, same with the salt crystallization. Our solution. If you can see, there's a remaining sugar that didn't dissolve in the solution. Okay, I use this stick and clipper. So this is a salt crystallization and this one is sugar crystallization. So we just wait 2 weeks to see the result.
2 weeks later.
So now we discuss. This is the result of salt crystallization. Salt crystal formed by evaporation. Over several days and weeks, we watch how the solvent evaporated, which caused the concentration of the solution to go up past the saturation point. So, precipitation occurred. The more solvent evaporated, the more crystal formed. Once the solvent was entirely evaporated, all the halide had precipitated and crystals stopped growing. This is the result for sugar crystallization. Crystallization formed by cooling. Precipitation of the solute into crystal happens when a warm solution cools, causing the concentration to change. The warm solution may already be saturated, but it doesn't have to be. The solvent is less dense at higher temperature. There is more space between the solvent molecules for the solute to dissolve. So you can dissolve more solute at higher temperature than at lower temperatures. If the solution reaches saturation point, any extra solute will be precipitated from solution. Fun fact about the sugar molecule is that they prefer to attach existing sugar molecule or crystal formation rather than to start new crystals. So, what we can conclude, all liquids have a set solubility in specific substance. Some liquids have high solubility or low solubility. Solubility refers to the amount of substances called the solute that can be dissolved into a liquid known as solvent. In most cases, as the temperature of solvent increases, the solubility increases as well. In this experiment, we started at 100 degrees Celsius of the water, where the water is at boiling point. At this point, the water solubility is high enough to dissolve salt and sugar. As the temperature is at the maximum, the solubility of the water drops as well. This causes our solution to to release salt and sugar molecules. These molecules will form a solid crystalline precipitate. Overall, as the temperature of solution drops, the crystal molecules become more attracted to each other, falling out of the solution, therefore crystallizing faster. I hope this video will give benefit for you. Now, you can grow your own salt and sugar crystallization by your own at home. Thank you for watching.